decades ago, maps were large pieces of paper folded multiple times to fit in your backpack. Tourists in famous cities walking with a large map held with both hands were a common sight till late 2000s. When the smartphone revolution took over the world, that large messy paper we called a map was transformed into an app. The limitations of a paper map are extensive. Primary among them was their perpetual obsolescence in a rapidly changing world. Only maps of famous large cities were readily available, while mapping rural and urban areas was never considered. Now we can monitor real-time traffic and plan our journeys accordingly. The entire Earth, down to the tiniest village, has been comprehensively mapped, thanks to the help of satellites. The Global Positioning System, GPS, was developed by the US government in the 1970s for military purposes. It became available for civilian use in the 1980s and is now widely employed for various applications, including navigation, mapping, tracking, and timing. There were 31 satellites in the GPS constellation, 27 of which in use at a given time, with the rest allocated as standbys. More satellites are now in orbit and available as spares, enhancing the precision of GPS receiver calculations through redundant measurements. The satellite constellation orbits the Earth at an altitude of approximately 20,000 kilometers and transmits signals to the ground receivers. GPS can provide location accuracy within 20 meters and time accuracy within 40 nanoseconds. The Indian Regional Navigation Satellite System IRNSS, with an operational name of NavIC, is an autonomous satellite navigation system developed by the Indian Space Research Organization ISRO in the 2010s for regional purposes. It became operational in 2020 and is primarily utilized for precise real-time positioning, timing services, and messaging in India and its neighboring regions. The reason India built its own navigation system was to reduce its dependence on US technologies. During the Kargil War, India requested GPS locations of the enemy camps from the USA, but this request was denied. This incident prompted India to recognize the necessity of developing its own navigation system, leading to the operationalization of NavIC after years of rigorous testing and development. NavIC relies on a network of several navigation satellites that orbit the Earth at an altitude of approximately 35,000 kilometers and transmit signals to ground receivers. NavIC can provide location accuracy down to 10 meters and time accuracy down to 20 nanoseconds. India is not the only country with its own navigation system. For example, Russia operates GLONASS, a global navigation system. China has Beidou, a regional navigation system similar to India's. The European Union has Galileo, a global navigation system, and so forth. While India currently focuses on its regional and neighboring areas, ISRO plans to expand its coverage globally in the coming years. Here is the side-by-side comparison between the GPS and the NavIC satellite navigation systems. As you can see, GPS and NavIC share some similarities and differences. As anticipated before, GPS offers global coverage, while NavIC's coverage is regional, primarily focusing on India and nearby countries. Both use two frequency bands, but GPS uses the L1 and the L5, while the NavIC uses the L5 and the S1s. The L5 band is common to both systems and is used for civilian applications, while the S band is exclusive to NavIC and is used for military applications. In terms of accuracy, NavIC has an edge over GPS, as it can provide better position and time accuracy. This advantage arises because NavIC employs geostationary satellites on geosynchronous orbits with fixed position relative to India, maintaining a continuous direct line of sight with this region. In contrast, GPS relies on semi-synchronous orbits, which do not have a fixed position relatively to any specific location and complete two orbits around the Earth. The relative motion of the GPS satellites with respect to planet Earth allows for global coverage, but the accuracy of the signal depends on the particular geometric arrangement of the satellite constellation in relation to the receiver's line of sight at any given moment. Compared to the GPS signal, the NavIC one always comes instead with a beautiful close to 90-degree elevation angle, facilitating access to devices even in densely populated urban areas, thick forests, or mountainous regions, granting greater resilience against changes in the atmospheric conditions or human-made sources of interference, such as the multipath effect. In terms of market availability, GPS is integrated into virtually every smartphone. In 2019, ISRO forged an agreement with Qualcomm to introduce NavIC-compatible smartphones to India. Today, nearly all new chipsets come equipped with built-in support for NavIC. Recently, the Indian government held a confidential meeting with representatives from major smartphone manufacturers, as reported by Reuters. According to the report, the government is actively encouraging manufacturers to ensure NavIC compatibility on all new smartphones. I hope you have learned something valuable from this video today. If you did, please give it a thumbs up and share it with your friends. Also, let us know in the comments below which navigation systems you prefer and why. And don't forget to subscribe to Numerrig for more tech videos like this.